So now we're going to be looking at using the cosine rule. So I've written here that focusing again on the concept of a non-right angle triangle, we're going to draw a perpendicular line from angle B to side B. So I'm going to start by doing that. I'm going to draw my perpendicular line down the center here. So perpendicular, creating a right angle triangle, a right angle, and from that we've created two right angle triangles. So the second thing I've said here is we're going to let D be the point where the perpendicular line meets side B. So I'm going to call that point D. Let the length of the perpendicular line be H. And then what we're going to do is let AD be X units. So that's going to be X here. We know that the total length, between, and I accidentally wrote D here. Should have written C. So we know that the length between A to C entirely should be length B. So I'm just going to write that there, which means that the length DC will be B minus X. So we know the length between BC will be A and the length between AB will be C. So what we can observe now is that we can actually create two right angle triangles. I think it's just going to be easier if I do draw the two right angle triangles because we're going to use Pythagoras then to do a couple of proofs. So I'm going to draw my two right angle triangles. So the first one being triangle ADB. Then we've got our other right angle triangle, which is going to be C, B, and D. So using Pythagoras' theorem, we can find the following. So just follow along with what I'm about to do. So focusing on, forgot to label this actually, sorry. So starting with triangle ADB, using Pythagoras, we can arrive at the following. And I'm going to call this equation 1. So now I'm going to write an equation for triangle CDB. So that'll be triangle CDB, and the equation for that will be a squared is equal to h squared plus b minus x all squared. So I'm going to call that equation 2. Now first up, what I'm going to do here is I'm actually going to rearrange the equation for triangle ADB. So transposing that, we get c squared minus h squared is equal to x squared. Then I'm going to expand. So that's going to be a squared is equal to h squared plus b squared minus 2bx plus x squared. And that's going to be equation 2 still, and that's going to obviously be equation 1. So now what I'm going to do is actually substitute equation 1 into equation 2. So doing that, I'm obviously going to substitute c squared minus h squared, where x squared is here. So I'm going to write a squared is equal to h squared plus b squared minus 2bx plus c squared minus h squared. So from here, I'm going to collect my like terms. So h squared and minus h squared are going to cancel out. And that's going to leave me with a squared is equal to b squared minus 2bx plus c squared. So coming back to this now, we've still got a variable here, and I'm going to highlight that it's the variable x that we're after, that we can sort of flesh out a little bit further. So if we come back to the triangle ADB, so let's take a look at this triangle here. If I asked you to find the length x using triangle ADB, you'd automatically think the trigonometry ratios, and in that case you would be correct. So you'd be thinking cos of an angle is equal to the adjacent over hypotenuse, remembering that the adjacent is next to the right angle and the reference angle, and then obviously C is our hypotenuse, making H our opposite length. Being that I've asked you to find the adjacent side, so subbing in what we know, so we know cos of angle A is equal to x divided by C. Rearranging this expression here to let x be the subject, I'm going to have x is equal to c times cos of a. And what I can do now is I can actually substitute this into here. So by that I mean I'm going to do a squared is equal to b squared minus 2b, and instead of x I'm going to substitute c times cos of a. So that's going to read as 2bc times cos of a plus c squared. I'm going to rearrange this a little bit more to just make it look nice and tidy. So I'm going to do b squared plus c squared minus 2bc times cos of a. This particular rule that we've just proven is actually called the cosine rule, and this is a generalization of Pythagoras' theorem. I've written here in a similar way, if we drew a line from side A to angle A or side C to angle C, then we would actually arrive at the following equations. So for example, we would end up with b squared is equal to a squared plus c squared minus 2ac times cos of angle B. And then we would have c squared is equal to a squared plus b squared minus 2ab times cos of angle C. So these are the three cosine rules that we can derive depending on what I've asked you to find. So for example, if I've asked you to find length A, you would use the first cosine rule that we've found. Having said that, it does require you to have the angle A given to you. And then if I asked you to find length B, you could use this equation here, or if I asked you to find length C, you could use that equation there. So all of these equations do require you to have the interior angle, or the angle for the length that you're trying to find. So for example, let's draw a right angle triangle here. Sorry, not a right angle triangle, a non-right angle triangle. Let's say, for example, that A is equal to 5, C is equal to 11, and angle B is equal to 81 degrees. So here I'm going to say, find the length B. So labeling my triangle now, I'm going to write ABC. So here I'm going to say that that's 81 degrees. Length A will be opposite to its reference angle, which is 5, and then C, or length C, sorry, will be here. So obviously here we're trying to find B, which is what we don't know. So I'm going to let B equal B for this case. So to find the length B here, we're going to be using this particular rule here, which says b squared is equal to a squared plus c squared minus 2ac times cos of angle B. So that's quite a mouthful, so I'm just going to write this down now. So b squared is equal to 5 squared plus 11 squared minus 2 times 5 times 11 times cos of angle 81. We're going to get the length B equaling to 11.72, and that's it. So that's how we can use the cosine rule to help us find the length of the unknown. As you can see here, we do need the angle that's between the two lengths, so we needed this angle here. So just make sure that you do have it if you are looking to use the cosine rule. So moving on to the next page, I've written the following statement. So the cosine rule can be used in the following scenarios. So 1, if we are given 3 sides of a triangle and we're required to find the included angle, or an angle. And then if we are given 2 sides of the triangle and the included angle, so this is the included angle here. In this example, the included angle was 81 degrees. So I've written here as well, just in case, the included angle is the angle between the 2 given sides. So these are the 2 conditions that we need to have in order to use the cosine rule. So the example here says to find the smallest angle in the triangle with the sides 4, 7, and 9 centimeters. So again, drawing out my my non-right angle triangle. So I'm going to have, let's say that that's A, B, and C. So I'm going to say this is 4 centimeters. So this is length C. Length A can be 7, and then length B can be 9. So these are all obviously in centimeters, so make sure that you're, well, in this case, we're asked to find the angle, so it doesn't really matter, but if you are asked to find the length, you need to make sure that you're giving your answer back in the units the question was given in. So here we're going to have to actually rearrange the rule, right? So for example here, we're asked to find the smallest angle. The smallest angle actually corresponds with the shortest side, so we're actually trying to find angle C. So here we're going to use the rule, or we're going to rearrange, the rule C squared is equal to A squared plus B squared minus 2AB times cos of angle C. So we're actually going to rearrange that, and in doing that, what we're going to do is get C, the angle C, by itself. Subbing in all my values now, I'm going to get C is equal to, so the inverse of that, I'm going to end up with C is equal to 25.20 degrees. And that's it.